This video is going over how to find the critical pieces of a rational function. Specifically, we're going to talk about how to find the x-intercepts, the y-intercept, as well as the vertical asymptotes. There's obviously more pieces we need to find to graph a proper rational function like the horizontal asymptote or the oblique asymptotes. However, we're going to say that for another video because it's a little bit more detailed. So this is just a follow-up video. If you need to see how to find those basic pieces, the x-intercept, the y-intercept, and the vertical asymptote, where I kind of break it down and explain it further, find that video. I put a link down to it in the comments. All right, but this is kind of quick how to find those things. Let's start with number 17, for example. So number 17 is f of x, and then 3x, x plus 1, or x minus 1, over 2x squared minus 5x minus 3. All right. So, first thing I want to find are the x-intercepts. So let's start with the x-intercepts here. I'll do it in purple. All right, to find the x-intercepts, we set the numerator equal to 0, because, right, in any fraction, 0 over something, it's still going to be 0. So the x-intercepts, we plug in 0 for y, which the y is over here, is f of x. So I'm just going to set the numerator equal to 0. And again, if you're like, well, wait, why not both, the top and the bottom? I recommend you watching the video that I posted earlier. All right, so I could set each piece equal to 0, so 3x equals 0, and x minus 1 equals 0, using the zero product property. Divide by 3, x still equals 0, that's one of my x-intercepts. And then add 1, and x equals 1. That's another one of my x-intercepts. Cool, so two x-intercepts, that's totally acceptable. We can absolutely have two x-intercepts with rational functions. All right, the next thing we want to find is the y-intercepts. So with x, we plugged in 0 for y. So for the y, we want to plug in 0 for x. Okay, so we're going to have f of x equals 3, 0, 0 minus 1, then 2, 0 squared minus 5 times 0 minus 3. All right, so up here it's going to be 3 times 0 times negative 1. What doesn't matter because 0 is up on top. It's just going to be 0 up on top. Now, actually, I don't even have to do the math down here, but 0, 0, so negative 3. So 0 over negative 3 still equals 0. So the y-intercept here is going to be 0. All right, and then lastly, let's find the vertical asymptotes, which, again, I will repeat from the last video, is just like finding the domain restrictions of this function, because as you know, if it's a rational function, that means I have to worry about the denominator being 0. So vertical asymptotes are where my issues are. So I'm going to solve the denominator here, so 2x squared minus 5x minus 3. And set it equal to 0 to find out where it does equal 0, and those are going to be the spots where my asymptotes need to go. So it's quadratic, so I need to use my quadratic tools to solve this. So I'll go ahead and use x factor here at the start. 2 times negative 3. A times c is negative 6. Negative 5 on the bottom. Two numbers to multiply to give me negative 6. Add to give me negative 5. I believe it's going to be negative 6 positive 1, correct? Now, normally you're like, oh, there's a shortcut to this, right? I can't use the shortcut this time because notice that a is not positive 1. The number in front of x squared is 2, so I actually need to do the entire grouping process here. So 2x squared, I'll take the first number there, minus 6x, plus 1x, minus 3 equals 0. Group them now. Factor out of 2x from the first parenthesis, leave me with x minus 3. And then this is x minus 3. I'm sorry, in the grouping process, just in the second parenthesis, where it's 1x minus 3, I have to factor out something in the grouping process. If I factor out a positive 1, it doesn't change anything. And the parentheses match. That's the goal of grouping. So I have x minus 3 here. And then the leftovers, 2x plus 1, go here. Equals 0. And then if I solve each one, it's eventually going to be x equals 3 and x equals negative 1/2. So these two values are where my vertical asymptotes are going to be, or where my yeah, where my domain can't be, right? It could be anything else except those two numbers, and so we'll put vertical asymptotes there. All right, so remember, this is all set up for graphing it, but there's still one more piece we need to find, the horizontal asymptote, which we'll do in another video. But this is how you would kind of quickly go through this kind of example for number 17.